Yes,
Okay.
I can record now. So we are actually recording the meetup. Go ahead.
Okay. So hello, everybody. We have, Maro and Jackson and I have talked about or decided to begin this coding help desk program, or whatever you want to call it. And basically, we want to set aside, each of us has set aside 2 30-hour or 30-minute blocks per week, where we put it in our calendar that this is time we're doing the help desk, and we would like, if other people in the organization would like to sign up for those times and do a kind of like live coding session with us. And the idea would be that maybe you have a real world problem or something that you're actually trying to figure out on your own, and you'd like to do a session with us and work on it together. So hopefully this might, well, one, resolve whatever problem you're working with, but we thought it also would be a cool way to encourage more like interaction and get used to each other's coding styles and this type of thing. So it's kind of an experiment, but we'll see how this goes. Hopefully some of you try it out. All three of us already have these events in our calendars. So you can see on Jackson's screen here that there's a coding help desk repository in GitHub, which has some instructions about how to use it. But basically, if you go into your Google Calendar and you in the other calendars section, you add Maro and Jackson and my calendar, and then you click the checkbox on it, then you should be able to see our events. And we have events in it. Thank you, Jackson. Oh, I only see Jackson's. Where are Jackson's? Tuesdays. Where are yours, Jackson? Can you click on mine? Okay, here's mine. So for instance, yeah, I don't know why I don't see everything. Here they are. So I have 2 help desk sessions on Thursday. So if you wanted to do this with me, then you come and look at my calendar. I will always be on Thursdays. Mara's will always be on Wednesdays. Jackson's are always on Tuesdays, at least for the time being. Yeah, and if you want to schedule this time, if you see that this block is here, then you can add an event on the same time and just invite me, and then I'll accept the event and delete this like time block holder from my calendar. And yeah, then we'll meet over Slack, and we can, or you can share your screen with us and we can talk about whatever problem you're having. Or yeah, and it doesn't necessarily have to be a big problem that you're working on either. If it's something you want to talk about, if you in general like to use yeah, the tidyr package and you want some support or some ideas about how to use it just generally, we'd be happy to do that as well. So use it for whatever purpose you think is useful, or if you're just lonely.
I think especially it could be helpful also with Git questions. Often it's helpful if you have like Eureka moments where you can just go over it one-on-one and kind of really get into the workflow. And so it might be helpful to have more general discussions on that.
Yeah, so don't take it too seriously. Please use it. Please try to use it, because we think it'll be interesting and fun, and yeah, keep us connected and keep us learning from each other. So try it out.
Cool. I'm going to dive into the actual DS incubator because I feel the fear that we'll run out of time. But yeah, more on the help desk maybe next week or yeah, as we see if people are using it or not. If that's okay with you, CJ. Awesome. So we now have officially 2 packages published on CRAN. Woo! Which is super exciting and worth kind of having a discussion about. And what I wanted to do today was just kind of highlight what those 2 packages are, how to find them, how to install them, how to use them, how to suggest that they should have more features, and kind of contribute to the next release to CRAN when that time comes. And yeah, and just kind of go over that process in general. So the two packages that were published are r2dii.data and r2dii.match. And these are kind of the first two packages underneath the r2di suite, which is this name that we decided to use to distinguish all of the 2dir packages. And so I wanted to highlight first, how do we find out what we already have? So how do you it might be difficult to just know what these functions that exist are, know what they do, know where to find them. So the website that it's important to kind of keep an eye on is this main r2di package website. So essentially this is going to be this wrapper for all of the r2di packages that we write. And it's going to kind of include this entire r2di infrastructure just to have under one umbrella. And in particular, under this news tab, you can see release notes for various package releases. And so if you click on this, we see, oh, look, r2dii.match was published and is available on CRAN. And this is how you can install it, and this is how you can load it. We haven't fully finished up these news articles, but this is kind of going to be a place where if you're not necessarily paying attention to the coding channel, you can still see the progress that's being made with this suite of tools. Same thing for data here. This is a good tab to see for kind of if a package is released, if there's an important patch to a package that adds some new functionality that's really important, and also potentially some kind of simple samples of how to use common functions within the package. What we also have is this reference tab, which is going to have a global reference of every object in all of the r2di packages. And so this you can use to say, all right, I want to match financial portfolios with climate data. These are the functions that currently exist in r2di to achieve this. And if you click on this question mark, it takes you to the documentation for that function under that package's website. So we now are at the r2dii.match, this package website. And we have, essentially, this is just the function documentation. It's the same thing you pull up from the RStudio console, but just on a package down website. So I'll let you kind of go through this r2di reference tab on your own and kind of have a look at what's available, bearing in mind that this is not, r2di is not fully polished yet as a meta package. It's just kind of a good branch to have a look, or overarching kind of umbrella to have a look at before you dive into any of the other packages. So to see the actual CRAN publications, I have links here, and I'll post all of this on the DS Incubator GitHub repository. But just to have a look and confirm it to yourself, r2dii.data and r2dii.match, both present on CRAN, and we're going to be including URLs to our websites, respectively, for these packages. But this is the first release of both of these packages. And as I highlighted before, this is just the same links to the actual package documentation websites. So they have, it's kind of a standard way of documenting an R package online, but they'll have quick installation tips for how to install the package, as well as a very, very bare bones example. And then a more in-depth get started section, which tries to really highlight all of the functionality of the package in a easy to understand and read through way. So I'll let you guys also read the details of these pages at your leisure. But what I wanted to go through first is essentially I've just set up an RStudio session that kind of highlights most of the functionality that I think is especially useful in the first release of both these packages. And I'm just going to kind of blaze through a demo of it right now. And I'll include the scripts that run through this demo as well in the DS Incubator GitHub. And you guys can go through it again on your own and prove to yourself that the package is installed and everything works as you'd expect. So, can everyone see my screen? Okay. I should have asked that maybe a little bit earlier.
Yes, I can see the RStudio program in full.
Okay, fantastic. And is it big enough?
I think a little bigger would be nice, but if it's too uncomfortable to you, it should be fine.
No, it's okay. So we have two packages that are currently that have been released, and so I'm just going to kind of go through the motions of using those packages right off the bat. And if you guys have any questions, feel free to interrupt and just ask me. So let's just load the packages, and you can install, since these are CRAN published, and now actually we even have Windows binaries, and I think, yeah, they're available for installation relatively easily. So you can actually now install these packages as you would any other package in R, just by calling install.packages and then package name. And success. r2dii is now installed. And just to prove yourself that these packages load as you'd expect, you can load up both r2dii.data and r2dii.match as you'd expect it to load. So I want to look at r2dii.data first and just kind of give you guys an idea of what the purpose of it is and how it might be useful to you, and also how you may suggest other things to be included in it that makes it more useful to you. So the idea behind r2dii.data is to have a public-facing package that contains all of the template data sets that are necessary to do most 2DI analysis tasks. But since it's public-facing, have all of the data and all of the fields be completely synthetic and completely fake. And so this allows two things. This fake data can allow for demonstration purpose, or can be used for demonstration purposes, which allow it to become clearer to potentially external parties or even internal parties how to use each of the functions that we have. And the other useful purpose of this is to be used for actually writing tests. So to have consistent demonstration data that you can then use to kind of backtest to make sure that things are as you expect. And I mean, even if you don't actually use the demo data in this exactly for your tests, but just some spliced version of it, it's still helpful to have kind of a starting point where you know exactly what this data frame should be formatted as. So with r2dii.data loaded right here, the first thing I'm going to call is this function data dictionary. In fact, actually, maybe I can just type in the console over here, r2dii.data, : to see all the objects that are available in this package. If you can have a look at those separately. But this data dictionary file is a helpful metadata file. In fact, let's quickly call the documentation up for it. So by calling package name, : data dictionary, I was able to get up this documentation file for this data set. So what data dictionary is a data set that provides metadata about all data sets in the package r2dii.data. So before kind of explaining that, let's just have a look and you can see what I mean. So this data set is kind of encapsulates all that r2dii.data has to offer. And it includes data set names. So ALD demo itself, it itself is in fact a data set within the package, ISO classification, etc. All of these are just names of all the individual data sets. All of the column names within each of those data sets, the type of each of those fields within that data set, and then a brief definition of what that data set is. So for instance, ALD time step, data which asset data was pulled from database. This is helpful to kind of ensure that each column name is consistent and is also actually describing what you'd expect it to describe, and not some other random field that kind of conflicting names could have. For instance, if everything was just called name in every data set, you might not know exactly what that name refers to. So it's helpful to have concise definitions for all of those data frames. Now, that's this data dictionary meta object. We can have a look also at an individual data frame. And again, let's maybe look at the documentation first. We can always call up documentation for any of our data sets using question mark, package name, colon, along with demo. Or also, I mean, conversely, you don't have to specify the namespace of the package. So you can just call question mark loanbook demo if the package is loaded. I just like the explicitness of identifying the namespace. So let's have a look at this loanbook demo. And I mean, it's probably exactly what you expect. Fake financial portfolio. It's a fake loan book. It's a fake corporate bond or corporate debt loan book. And it's what I'm using to develop the bank's software and develop the bank's tests as I kind of move forward. So let's have a look at this data set. We don't have to go through it necessarily in column by column, but I mean, it just includes things that you might expect: ID loan, direct loan taker, name of the loan taker, et cetera, et cetera. Yeah, I mean, I'm not going to go over it column by column, but it's a fake loan book. And just maybe to highlight also that this if you filter the data dictionary for data set equals loanbook demo, you can then see all the column names that are going to be present in that demo. And you can do this for any data set if you're curious about what specifically each column name that's in these demo data sets actually represents and what was intended by the developer when they wrote that. So we have this kind of fake loanbook data. You can save it as a loanbook as an object in your global environment, and I mean, yeah, obviously I'm not going to go through an R tutorial, but you can you can save all of these data sets as objects in your global environment. We also have a ALD, a fake ALD demo data set. So this is a completely synthetic, like I just made up random numbers. It's a completely synthetic asset level data set that you can use for testing your code and testing new features that you're writing without having to use real data from Taylor every single time. So maybe that helps, I don't know. Beyond that, in r2dii.data, we have this classification bridges. So, I mean, I'm not going to get into detail, but these bridges essentially bridge from the ISIC classification standard to r2dii's classification standard. And we also have this meta file that has all sector classifications that we currently have bridges for. So.
Sorry, Jackson, just heads up that you have a little less than 10 minutes ahead.
Okay, good. Well, then that's enough for data. So the idea behind data is not necessarily that it's extremely useful on its own. I mean, it's a lot of demo data sets. It's helpful for looking at, but I mean, that may not come into your life directly. The real purpose for it is that it helps in developing all of the later infrastructure that gets written around it. So when we write kind of more the rest of the analysis workflow or the matching process or any other process that r2dii kind of includes in its analysis, it's easy. It's nice to be able to always refer back to this data package and always have a data frame that's going to be consistent and something that you expect. So to kind of show what I mean by this, I'm gonna load the matching library, and so I'm sorry, it's in the chat. Okay. So I'm going to load up this r2dii.match package, and now in the same way as before, there's documentation for the entire package. So you can pull up the documentation for the package itself by pulling up question mark r2dii.match, and this gives this kind of description overall of what this package aims to achieve. So this is really just fuzzy name matching for the bank's work. But in principle, it's going to be extended to all of the matching that we do between financial portfolios and physical assets. So we can run through a quick demo to show how easy it is to actually implement the matching. So by calling r2dii.data here, I'm saving these demo data sets into my global environment. So I now have loan book and ALD, which are these demo data sets from the last package. We also are going to need this, but I'm not going to explain why for now. And let's have a look at this function match name. So this is another function, one of the main functions that's present in this match package. And what it does is matches a loan book and asset level data set by the name underscore star columns. And so what that means is, you can read through the description yourself, but essentially it runs fuzzy matching algorithm between all names in a loan book data set that are formatted using this name underscore star system. So you name underscore direct loan taker, name underscore intermediate parent, name underscore ultimate parent. And it compares those against names that are in an asset level data set. So I'm not going to keep explaining, but to actually run this matching, it's as simple as calling match name, match name with the loan book and ALD arguments. I have it piped here, but you guys know what it means. It's just calling match name on these two objects. So it takes maybe about a second or 2 seconds to run. And now that's the entire bank's fuzzy matching process is almost complete, essentially. So we can have a look at that if you want. It's not, the interesting columns are kind of at the end here. This is the original name that was in the loan book. This is the name that's in our asset level data. And this is the score of the match. So you can see a lot of these are some perfect scores of 1, Aston Martin and Aston Martin. But if you sort from the bottom, you can see obviously Anhui Faida Cement and American Cement are not matches. They both have the word cement in them, but they're not necessarily good matches. And so, you have to go through and manually validate these. Before I get maybe too far into that, there's also, I just ran the match name with the regular arguments, but we also have this bisector flag. Bisector is only going to try and match between entities that are in the same sector across both data sets. So if you have a power company in one data set and an oil and gas company in the other data set, even though the names might be identical, it's not going to find those matches if bisector equals true. And you can read through the documentation for the rest of these arguments at your leisure, but it's all kind of present here.
Jackson, just heads up that you have about 4 minutes. If you can leave some minutes for questions, that'd be great. Yeah,
maybe I'll leave this now. You guys do that. There's kind of examples of how to use every argument further down here, and I'll just kind of leave this with you guys, and you can run through the script on your own. And also to highlight that pretty much everything I'm going through is really just what's on this Get Started tab. So if you want to look through the documentation and look through this r2dii.match file, and you go through this documentation tab in detail, you're going to get all the information that I was just going through now. So maybe I'll stop now and we can take some questions.
Thank you very much. Yes, I would love to hear what thoughts people have or questions or suggestions. I already saw some typos that need to be fixed in the demo.
Oops.
So the minimum score is, it will be NA if it doesn't find a match with a score higher than that?
No, so it actually filters, it subsets. It only shows the results with the minimum score that's greater than this threshold. So it'll cut those out. And also, because the thing to note is that it won't output a loan book that's the same size as the input loan book, because there's a potential for finding matches at various levels within the loan book. So if you have a match at direct loan taker, intermediate parent, and ultimate parent, you can have as many as 3 times the number of output rows as you do input rows.
Cool.
Can we
I
have
have a quick question?
Yes, please. I'd love that.
For the data package, is this where all the data will eventually come from then?
No. So the idea for the data pack, I mean, in principle, I think the way that we see it is the data package is where all of the fake data will come from. So the data package is meant to be kind of like a template for what each of these standard data sets should look like, to have an idea of how to get through the workflow. But whereas all of our proprietary data is still going to be through Taylor, it's still going to be processed in the same way. It's just meant to have, so that we have kind of like a standard kind of idea of exactly what each data frame represents and what all the fields are, and just kind of have a more standardized process.
Should we then be using this for testing to see whether the data files are in the expected format? Or how will we manage, like, if data files change structure?
Yeah, so this is something that we're going to have to, obviously the hope is that data files don't change structure so much, but of course that's going to happen. So when that does happen, yeah, I think the hope is that r2dii data adds a bit of a hurdle towards changing data structure, not to make it a hassle, but to make sure that if we are changing data structure, we're sure that it's a necessary change, and we think a lot about it and make sure that we are being a little bit more consistent about that. The idea with that is to have these more kind of like well-defined, like not God, but like ideal data set templates, and use that for all of our analysis. If they do have to change, or if you have a query or some kind of worry, just flag that in the issues file or in the issues tab of r2dii data. And this is kind of like already we have conversations going on this, for instance, here.
Okay.
So if there is any kind of query, or if you're saying, hey, where the hell's this? I need this. We have to chat about it and figure out how to resolve that, and if that needs to be added, or if it needs to be a new data set, or how we should go about doing that.
Sorry, guys, we ran out of time. I wish we had more time for questions. I'm sure people have them. Can you please direct the questions to us? Maybe if it's easy for you, in coding channel, and we'll make sure they land in the corresponding issues that we need. Thank you all very much. I say bye, and I leave Jackson the last word.
Bye.
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 Thanks, everyone.
Bye.
Bye.
Thanks,
if you have questions, of course.
Ciao.
Alrighty. Bye.